Welcome to converting between degrees and radians. Degrees and radians are just two different ways to express angle measure. The nice thing is that these equations are on your reference sheet, so you do not have to remember them. You just have to remember when do you use which one. And the way we're going to do that is we're going to start with what you're given. So let's take the first example. They're telling us to convert between degrees to radians. Now, this particular question gives us degrees. And if we're given degrees, we're going to use the formula that says degrees. That's what I mean start by what you're given. If your question starts out in degrees, use the degree formula. Now, that formula says 1 degree is equal to pi over 180 radians. But we don't have 1 degree. We have 45 degrees. So I'm going to multiply both sides by 45. On the left, I get my 45 degrees, and on my right, I have to figure out how to simplify that. Now, this problem does say to leave your answers in terms of pi. And anytime you see that, well, you should have a pi in your answer, and you are not rounding. So what this means specifically is don't round, and don't put pi in the calculator. Because if you put pi in the calculator, an irrational number, you're going to get a decimal, and you're going to have to round. So instead, what we're doing in the calculator is really, this is a 1 in front of the pi, and this is a 45 over 1. So in the calculator, you're going to do 1 over 180 times 45 over 1. And the calculator tells you that that would be 1/4. So I'm going to put my 1/4 here. But remember, you didn't put pi in the calculator. And there's supposed to be a pi in your answer. So you need to put it back in. Now, if pi was in your numerator, then pi should be in the numerator of this answer as well. So your answer is just that 45 degrees is equal to 1 pi over 4 radians. Or if you prefer, just write pi over 4 radians. Let's try another one. We're given degrees, so I'm going to start with the degree formula. 1 degree is equal to pi over 180 radians. We have 240 degrees, so I'm going to multiply both sides by that. And I get 240 is equal to something. In the calculator, we're going to put 1 over 180 times 240 over 1. Everything but the pi. And when you put that in the calculator, it's going to tell you that it is equal to 4/3. But remember, you didn't put pi in the calculator, so you need to include a pi in your answer. Pi was in our numerator when we started this, so pi should be in your numerator when you finish this. So 240 degrees is equivalent to 4 pi over 3 radians. Now, when you go backwards, we are converting from degrees to radians. And remember, this one says round to the nearest degree if necessary. So if we have to, we're going to put pi in the calculator. In this particular example, we are starting with radians. And if you're starting with radians, that means you should be using the radian formula. So I have that 1 radian is equal to 180 over pi degrees. I'm going to multiply both sides by what I actually have, because I don't have 1 radian, I have negative pi over 3 radians. On the left, I'm going to get negative pi over 3 radians is equal to something. Now, the nice thing about this is that a pi on the bottom crosses out with the pi up top. And all you really have to put in your calculator is 180 degrees times 3. And remember, your answer is going to be negative. So 180 divided by 3 is 60. And you can't leave out the negative. If you don't want to do it like that, in your calculator, 180 over 1 times negative 1 over 3, because when you cross out the pi's, you're left with a 1 there. And that will still give you negative 60. So negative 60 degrees is our answer. Let's try another. We're given radians, so we have 1 radian is equal to 180 degrees over pi. Multiply both sides by what you're given, which is 19 pi over 17. On the left, we get 19 pi over 17 radians is equal to something. Our pi's cancel out, and in the calculator, what you should be putting is the leftovers. 180 over 1 times 19 over 17. And if you put that in the calculator, you end up with 201 degrees. The next two problems are slightly different because if you notice, they don't have pi in them. We're not talking about pi over 3 radians, we're talking about 2 radians. But it's the same exact thing. We're given radians, so we should start with the exact same formula. 1 radian is equal to 180 degrees over pi. And then we really have 2 radians, so we're going to multiply both sides by 2. We get 2 is equal to something. Now, if you notice this particular one, they're asking you to leave your answer in terms of pi. And when they ask you to do that, their pi does not go in the calculator. We are not rounding. So the only thing that you're really going to put in the calculator is 180 times 2, which happens to be 360 degrees. But because you didn't put pi in the calculator, you need to put pi in your answer. Pi was originally in our denominator, so pi should go in the denominator of your answer. And I know it's kind of weird to say this, but 2 radians is equal to 360 over pi degrees, even though we don't really know what 360 over pi degrees is. If you wanted to get a good estimate, put it in your calculator and round. This one, same thing. 1 radian is equal to 180 degrees over pi. And we're going to multiply both sides by how many radians we have, which is 0.5. So 0.5 radians is equal to something. But notice that this particular problem says round to the nearest tenth. So all of this is going to go into your calculator. 180 over pi times 0.5. And when you round appropriately, we should be getting 28.6 in the calculator. So to sum it up, both formulas are on your reference sheet. Make sure you use the equation with the one that you're starting with. If you're given degrees, use the degree formula. If you're given radians, use the radian formula. And also, very important to pay attention to, is it telling you to leave your answer in terms of pi, or is it telling you to round? And that's it.